Good day, folks. In this lesson, we're going to go over how to update our physics sort of script. We're going to work on refining our box colliders, and we're going to add some sort of physics to our tile map. So let's get started. So last time we sort of noted that like when you would run the game and you'd have Ruby run up against something that had a box collider around it. So basically you had two objects that were kind of like colliding with each other, and it's like they kind of were, let me see if I can zoom in a little bit. So you see how it's sort of like jittering like that versus like just you come up against something and it stops. So this is interesting. So right now what we have in our script is we're hooking into our sort of position of the game object. Now we had to add a different component. We've got our rigid body 2D and our box collider. We just added those two components to Ruby as well as to our box. So these are kind of like two different systems. So what we're going to do with our script is we're going to change it so that instead of relying upon our like changing the game object, we're going to be instead working with when we move the moving sort of our character, we're going to be working with the physics engine. So let's go ahead and we're going to go to our scripts folder and work with our Ruby controller. And I'm just going to open this up in TextEdit. I think definitely down the road when I re-record all these, I'll be doing like Visual Studio, but for now we'll just do TextEdit, just because I know it's sort of easy. So for you, you'll probably just be able to, you could just double click on it. But anyways, let me just increase the size here. Okay, so a few things we're going to do. I'm just going to sort of like take it from the top. So let me go ahead and do this. All right, so we're going to be declaring some new different types of variables with this. We're going to be moving. We have this our horizontal and our vertical. We're going to change these from what are called local variables to global variables. So right now, only stuff, like only our code is only visible, like when it says horizontal and vertical, these variables are only visible within what's called the update function. So if you tried to reference those variables over here in start or in any other place where you would be kind of working with stuff, they would not be visible. Like whatever information you have stored in those variables would not be visible elsewhere. So we're going to start off and we'll just go ahead and just put this right below like our sort of like class declaration. We're just going to say, I'm just going to tab over. This does not change how it functions. We're going to say here float horizontal and then float vertical. So these, again, are two variables that we'll be utilizing in our code that will be visible to the entirety of our code. So everything between this bracket and this bracket, rather than before, it was just going to be what's between here and here. Okay? All right, so I guess, yeah, we're going to just delete the reference to like with the declaring part here where it says float horizontal. We're going to get rid of the float here and the float here. So that's going to be in the update function. Okay. Okay. All right. So float horizontal, float vertical. So I had also mentioned too that we're going to be changing some things up, like with what we're going to be working with our sort of just instead of using the game object, like the transform position thing, we're going to instead be working with the physics engine. So we're going to go ahead and say rigid, RIG, RIG, ID, body 2D, and then we're going to call this, that's going to be, it's capital D, sorry, rigid body 2D, and then we're going to give the variable name RIG, rigid body 2D, okay? All right. And also note the semicolon at the end of each of these lines of code. Okay, this will allow us to hook into the physics system so that when we're updating our position, instead of having it be the transform function for the game object, instead we're going to be having the physics system determine like what's a valid move versus an invalid move. Okay. All right. So in start, we're going to give information. So right here, we should be in our start function. We're going to start off and we're going to define this rigid body 2D variable. So let's go ahead. I just copied it RIG, ID, BODY, good. So we're going to go ahead and define that. So, but first, so we said just rigid body 2D equals, oops, not a minus equals minus. I want to say get component, and then it's going to be caret rigid body 2D, but it's going to be capital R, capital B, no, not capital B, the D, and then semicolon. Okay, so rigid body 2D equals get component rigid body 2D. What that's going to do is it's going to populate this variable with the current like physics information for our game object of Ruby. So this is basically going to be, so it's like we're going to give this a initial definition like when we first start the game. All right, because eventually we'll be changing it, but we need to at least give our code the starting information about what's going on, like where to start. Okay, cool. So we go ahead and we should have, let me just make sure I've got everything right. Yes, okay, good. In our start function, that's good. Our update function, that's good now as far as we've got horizontal equals input dot get access horizontal, vertical equals input dot access vertical. Good. So now we're going to go ahead though. We're going to create let's put some space here, and we're going to create, we're going to end this update function. So let's go ahead and we're going to put a squiggly bracket to close. Okay. So this should be, the only two things in update should be horizontal and vertical. Okay. Next, what we're going to do is, let's go ahead and we're going to say void, whoa, not all caps. We're going to say void fixed update. And then we're going to go ahead and just do an open squiggly bracket. Now, we're going to be able to keep some of the code that we had, but this is now what's going to be what's called our fixed update. All right. So vector2 position equals, instead of transform.position, we're going to instead use that rigid body 2D that we had defined earlier. So I'm just going to copy that. Transform.position is going to become, oops, I didn't mean to do that twice. Rigid body 2D dot position. So before we had relied upon the game objects like position up in that top thing as far as that. Let's just actually reference it real quick. Initially with our first, oh, come on, oh, it's going to import the code. I'm a fool. Curses. I just have to finish the code because it might error out. Oh, actually, no, it's okay. All right, so it's going to be upset for now. But initially, we were grabbing the position from here. Instead, we're going to start off with this rigid body 2D is where we're going to get. We're grabbing it from the physics engine rather than the game object position. All right, so let's keep on coding. Okay, vector2 position equals rigid body 2D dot position, and then position dot x is fine. Yes, this is fine. And then what we're going to change though is we're going to say, instead of transform.position, we're going to say rigid body 2D dot position. And it's actually going to be, we're going to say move position. And then the parameter we're going to pass to it is going to be position. All right, now let's make sure we're all good here. That should be closed there, closed there. Good. Let's save this. And then let's import and check. It'll take a little bit to import this. All right, so let's make sure that this is all good. All right. Make sure that we can play. And so now you see, instead of that jitter, where there's sort of like an argument between this component here, actually I guess it's not sort of like a component, but earlier there was an argument sort of between this, like how we were plugging into it and the kind of collision boxes that we had drawn around the different objects. So now everybody's happy. Now the physics engine is what's basically being plugged into when it comes to updating, and it doesn't allow things to jitter. Okay, cool. I had alluded to the fact that we're going to be working with refining our box collider. Let's go ahead and do that right now. So let's go ahead and with our box collider, this is right now I have Ruby selected. We're going to change it. I just zoomed in. We're going to change it so that the box collider is instead going to be just around the feet of Ruby, sort of like the bottom portion. This is going to make it so that like you can kind of pass behind an object. So it just kind of like works a little bit better. So we just went ahead and adjusted the box collider for her. And I'm going to go ahead and also push that to the master because I just adjusted something in the version of Ruby that's in the scene. I need to push that to my my prefab. So go ahead to apply all. Good. All right. So the other thing we need to do as well is let's go ahead here and why am I doing that? I can just do click and drag. Okay. The other thing we're going to do is adjust the metal cube. So this box collider here is going to be set so that it's just sort of the bottom portion of it, rather than kind of like you see how it's like, you're not going to collide with a shadow. You want to be able to go through a shadow. So let's go ahead and go to this box collider, and then we'll adjust this down to just like, I don't know, like the bottom portion. I kind of captured this. There's no right answer to this. It's just sort of like a one thing to kind of play with. Let's do a little bit in. Okay, good. Let's just test this out quick. All right, so we collide there, but we can still sort of pass behind the object. So that looks pretty good. Okay, last thing for this lesson. We're going to be adding it so that we can walk on certain tiles, but then we can't walk on the water because it's not that type of game. Okay, so we're going to go ahead. Oh, metal cube. We also got to push to our prefab. Okay, you could at this point go ahead and add box colliders and physics to your other prefabs, like kind of the refining process, but we don't need to do that right now. Okay, let's go to our tile map. All right, so we're going to add some components. There is something called a tile map collider 2D. Now what that does initially is you see green, it's like, all tiles, bad. All tiles should have a box collider around them. Nope. We're going to remove this sort of the colliders from the majority of the tiles. So let's go ahead to our tiles folder and click on the first sort of tile, and then press and hold your shift button. Hopefully yours are imported like this, and then select all of them that are not water, and then where it says collider type, set to none. Now if we go to our tile map, we see that the only items that have box colliders around them, because it's green, is the water. Now, this is fine. This is okay, but you're going to have a huge amount of processing being done because it's basically treating these as like individual objects that need to have like physics simulated. So like right now, the physics are simulated for the box, the physics are simulated for Ruby. And so that's not bad, but then if these, since they're all individual tiles, they're like the computer's like, okay, I got to make sure that if anything changes with this, like gravity, the mass, if something interacts with me, I got to be ready to simulate the change. We don't want the computer to have to do that, so we're going to basically freeze them in time, so to speak, and we're also going to make it so that the all of water tiles are interpreted as like kind of a composite, or kind of like as one piece. Okay, so we're going to go ahead and add some things to our tile map. Okay, so we already added tile map collider 2D. we're going to go ahead and use a Composite Collider next. So let's go to our Add Component. We'll say Composite Collider 2D. All right. And we're going to go ahead to the, it's going to add some physics here as far as this. And we're going to go ahead and change one thing in our tile map collider. So where it says tile map collider, we're going to go ahead and say used by composite, because we're going to basically be handing our tile map collision detection to the collider component. So used by composite. Okay. And then where it says rigid body 2D, we're going to set it to the body type is going to be set to static because it's never going to move. All right. And then we are going to, actually, no, it already did it. So the composite there, set it up so that like instead of individual tiles here, it's instead like big blocks. So it's pretty neat. Okay, big lesson, a lot of stuff being covered. Some of the things too, like I gave, I think a decent explanation to the like what we did with our code, but the text instructions that are linked in Schoology gives you the line by line sort of like what exactly should have happened, or what exactly is happening in each of the lines. So if you are curious about what your code does, and my explanation wasn't enough, I think the text-based instructions work really well too. So we did it. I wish you the best of luck. Great stuff.